All right, so welcome everyone to this nice and close community meetup of the MeteorNL Meetup. I'm really thankful for you all coming out and making it on this night to join us for a couple of talks about Meteor. So my name is Peerdeman. I'm the lead tech at Lively. It's a company where we create web applications with a team of 10 in this nice office here in Amsterdam. And tonight we're going to have two talks. One is from I will deliver myself about some of the projects we did and the transitions we made in the stacks. Then we'll have a little break. We can grab a beer, and then Jesse will give a couple of nice practical tips and do a little bit more of a coding deep dive in some of the challenges that we encountered and that we solved. In our process of doing stuff with Meteor. All right. So you're at the Lively office right now. We do web applications. We do everything from start to finish. So we have conceptors, designers that work with our clients to think of a nice solution that will either increase profit, create new profit, or cut back on costs. We create the wireframes and the concept for it. We develop it. We do the DevOps. We host the stuff, put it online, release it, test it out, get it implemented, and then do a little bit of the analytics at the end and evolve the product further. So it's basically like the full chain, and that's where Meteor came in for us very nicely as well. All right, so I wanted to talk about our stack evolution. So we've been running the company now for 4 years, and we started doing backend in PHP and Angular. And I'm going to talk about the part where we switched to like full JavaScript and transitioned into Meteor. By the way, if there's any questions, please just raise your hand and start the conversation, because we have a nice close group, so we can just answer a lot of questions as well. All right, stack evolution. So Meteor application history in a nutshell. We have a couple of projects. We started with bundling, which we did in Node.js, just REST backend and Angular. Then we switched to Peerdeman. So a couple of you probably have already heard of Peerdeman. Maybe a show of hands who has already seen something of the product. That's nice. I'm going to talk about it more in a second, but that was our first big Meteor project that we did in DDP, and we used Blaze, which is still running, still using Blaze. So that's a big plus for Blaze as well. Then we transitioned into Star Dashboard, where we kept using Meteor, still using DDP, and switched the front end out to the React. We're currently working on codename School, which is an application also written in Meteor, now using GraphQL with Apollo and using React in the front end. And the next big thing that we're ramping up for right now is going to be Node.js with GraphQL and React. So you can see a little bit of a pattern there, and I'll get to why we're doing that in just a minute. All right, so maybe I'm going to introduce each of the projects like really shortly, that you have like basically an idea what it is. So bundling was our first project. Was like our sort of a startup project that we did as a side to the client business. We created a very nice interface for you to collect some links and make a very nice visual lookbook of a collection of links. You can actually still use it online on bundling.com. Written in Angular, and was our first project that was purely JavaScript. So for us it was really important that we made the switch from doing backend PHP and frontend Angular, and get these two teams far more closer and working in the same code base, which was basically our first step to using something like Meteor that really supports this well. So we had a RESTful backend. We created REST routes in Express, and we created this front end in Angular. Very rich animating interface. If you go to a bundle, it will slide in and give a nice visual experience. So bundling was also known as the first time JavaScript only. Yeah, tried to give a little bit of a nickname for each of the projects that we did. Yeah, which was very important for us as a turning point of getting getting more of a full stack role in the team. All right, so bundling. Things that were really good with JavaScript in the front and the back end. So this meant that the crossing of back-end developer and front-end developer working in each other's work was just far more closer and easier to do. Yeah, we had a large focus on the front-end application, really put work in it to make it a very nice, worthwhile visual experience. Yeah, we had some very heavily cached API endpoints, which was also like very easy to do using simple Express endpoints and making sure that it could handle a lot of requests. And then I was thinking in this slide, I'm going to use a thumbs up. I'm not going to use the thumbs down because it's not just only bad, but it was stuff that we learned and that we improved upon next time. So, well, I picked a rocket because I was tired of looking through all the emojis. I could not find like the thing that really captured it better. So we're going rocketeering to the next level, and that was one of the reasons that actually led us to Meteor as well, because we had to make a lot of decisions in choosing which packages to use. So when you use Node.js, like completely bare bones, you need to pick your own ORM or relational data mapper. You need to connect to the Mongo backend. You need to create your own development environment scripts to get your node running, to get your Mongo running. And for us at the start, this was well, we spent a lot of time doing this, and we managed in the end. But yeah, that's something that Meteor really helped us with in the following project. So we had a large initial setup for deployment as well. To just get it running, we needed to create a server, and have it like the Nginx stuff, and getting Node on there, and making sure that it's the right version, and all this kind of stuff. So that's basically where we started out. Then we got to the next part, which was Peerdeman. This is how it looks now. It has had a couple of iterations in recent times. So we started this, I think, 1.5 years ago with just 3 guys that had this idea of we want to revolutionize the way people work together. So it's a platform to create temporary projects together and get people matched to do a project. And we're still working on this and improving this, but this has been running on Meteor Blaze for the last 1.5 years, and yeah, it's been received very well, and they have had nice successes getting this out to their customers. And that was our first big Meteor DDP Blaze project. Also still running. So if you go to Peerdeman.com, you can see it running, and if you open the inspector tab, you can actually see all of the subscriptions and all of the images and all of the users and all of the stuff going on reactively through the WebSocket. So Peerdeman is also known as the cutting edge, like a new way of designing a product with real-time data. So the notifications that you could see. Here on the top right, you have notifications. You have a whole chat where you could chat one-on-one, but you could also chat in a group. You can chat on your mobile phone. It's a very yeah, it was a very good platform for doing these real-time interactions. So what was great the first time when we started with Meteor, we had I've written it down as a superior development experience for people that onboarded the team. We also, even quite recently, someone else joined the team. It's an open source project now, and he was basically able to get started in the code on the same day that he checked it out. So he just checked out the project, ran a Meteor command, and he was just instantly running, and he could be productive within seconds. Well, that's something that's been very unique for us, and I think still is one of the points that probably the people who are starting with you is. It's just a really great feature, and you're starting to see more of these kind of methods of getting this one word of like npm start, and then it automatically boots up your Mongo and something like Meteor. But I've actually not seen these kind of one-click setups that works as well as Meteor does now. Another big plus is that it's an opinionated framework, so a lot of decisions for you how to do stuff the Meteor way have just been made for you. There's this Atmosphere, before it was Atmosphere, this package manager for Meteor, and if you wanted to do accounts, you just installed accounts, and it was there for you. And, it sent emails and let you reset your password, let you log in, let you register, and for these kind of functionalities, there's really nice packages that you could just pull into your application and just get started working on the core value of your project, which was really great for us. Yeah, and you don't have to make all these decisions yourself all the time, and that's really supportive if you don't know about all the options yet and you don't know about the restrictions of the packages yet. Okay, so notifications and real-time chat, they were real breeze to program. I already said this before. Another nice point is that we launched a hybrid app written in Cordova with Meteor, all on existing DDP APIs. So it was, of course, not completely only the DDP API that already existed, but I think there were a couple of things that we had to edit, but we could actually just create the app and you reuse almost all of the API that we have already created. So that was great. Just a couple of places where the website would pull in far more information than the mobile client would actually need. But this was a relatively painless process, which was a great plus. All right, so things that we could improve. We found that the subscriptions were pretty heavy and had lots of data, especially when they were like scaling up. So you would have a project, and we would always test it with or maybe 10 people, or we would have the whole office like log into the chat room right now and try to spam it and get it broken. And we couldn't get it broken. It was a nice test, and we did some load tests as well with some scripts that did some subscriptions. But then the product goes live, and there's this group of, I don't know, 300 people that start hammering the service, and then you immediately find out that there's just too much data being sent. Which was actually quite a challenge to manage effectively. And in the end, we were prepared by this by doing horizontal scaling. So we just put more boxes, more machines next to each other, and we could distribute the load while we were working on decreasing this amount of data that was being transmitted. It's not really a fault of the Meteor platform, but it does make it very easy for you to just send out a lot of data. So that's maybe something to keep in mind. So it was a little bit harder to scale, but we found our way in this. And this was all before Galaxy existed. I don't know who knows about the Galaxy hosting platform here. Okay, there's a couple of people. Yeah, but yeah, the guys from Meteor know this very well. But this makes it a lot easier to host your Meteor application. Make sure that this third party just takes care of the rest. But it was not there when we needed it before, so we had to kind of like do it ourselves. All right, so step 3, which was a start dashboard. It's an intranet, a place where a company can have their discussion internally, and with a real-time chat as well. And all this data is being stored on site. So for this project, it was very important that the data would not go to Facebook or have WhatsApp chats. And they wanted to have a very WhatsApp-like experience in their website, but have complete control over all the data. So we used Meteor again because it was just the nice ecosystem that we were already very used to. Used DDP to make sure we had the quick setup for the subscriptions and the chats and having everything real time. So. And then the part that we switched out was using React for the first time, which was a great plus. I would like to know, like, who's using React now for the front end? Anyone else using something else for the front end now? Yeah, in the back.
Yeah, it's called Riot.js, which is based on the ideas of React, but I like it better.
You like it better, all right. So this using a Riot.js as a with the same kind of place, maybe a little bit like a Vue as well.
Oh, I don't know that.
Okay, no. Also, it's similar to React, but this was really a great plus for us. So basically, this project became reactive everything in React. So everything was reactive. All of the articles updated reactive, and we had everything with subscriptions. So we had to make really sure that we did not send too much data, because, well, someone would join a group and then all the invitations would go out, and it would turn into a notification fest of sorts. Reactive everything in React. Right. So in this project, we were really refining upon the stack even more. And one of the best points in this part of time was that we had ES6 from the get-go, which was also our first experience with using ES6. The things that were most important were the imports and the use of NPM modules, and that was also the part where we saw Meteor shifting more. So it started as this full solution on top of Node.js, and this was the first sign of us that we saw of Meteor slowly migrating back to the Node.js ecosystem and using more of the Node.js ecosystem without having to wrap everything in an Atmosphere package and having it pulled in through the, well, not proprietary, but the different package manager than just using NPM. And that gave us a lot of freedom to actually use some other NPM modules without waiting for a certain package to exist, and we could just use the existing Node.js documentation to get everything started. And ES6 was of course nice with syntactic sugar, but definitely the import, so being able to organize your code and having control over which component we would import in our client and in our server really helps structure the thing a lot better. Okay, then of course we had React, which was a big relief over Blaze. In comparison, I always see it as that Blaze compared a lot more to Angular, and you had more local state and stuff interacting with each other. While in React we had this very nice model of getting the data in, just having the DOM components, and having less state affecting stuff outside of your component, which was along with a new way of structuring our styling more on the React components, really gave it a feeling that you had far more control over the strange stuff happening in your interface. Again, great platform for notifications and chat. It had built-in notifications on top, and the chat was also. We were able to think about the stuff that were very heavy in the previous project, and we're now able to slim it down to a minimum version that would just get the data out quickly. It was a very nice start. Fun part of this project is that all of the stuff that you see, the articles and the messages and everything is indexed in Elasticsearch. So we are using Elasticsearch as a Docker container next to the Mongo Docker container to actually run this the Meteor program. And it was actually quite accessible to integrate these two, because we were so close with the NPM packages to just use the Elasticsearch API that we were able to easily index documents. Who already knows what Elasticsearch is? All right. So Elasticsearch indexes documents, and you can easily find through them. So, for instance, at Star Dashboard, they would upload lots of big PDF documents with a lot of text in them, and then when it was uploaded, we would actually scan the document and put it in Elasticsearch, and then then the next document, then index it into Elasticsearch, and when a search is being made on the front end, it was just query Elasticsearch and ask if I search for the word guitar, which documents match this, and they would just give back a document, and then in Meteor we would present this information back. So you have a very quick search without having to open each file, each PDF file, and looking through to see if the word guitar is somewhere in there. So that was a very nice accessible part. Yeah.
What was the reason to have Mongo in your own containers and not using like a third-party service?
So the question is, why did we use Mongo in our own Docker containers? Because for this client it was very important that you would be able to run this complete solution on premise. So you would have full control over your data. So when the application is being deployed, we install it with Nginx and Fusion Passenger, and we run the Docker on the box itself. So you would have full control and not have anyone being able to access this machine other than the place where the box is being hosted.
But it's physically hosted on the.
It's on the same machine as the web application. Yeah. And then with Docker you can easily expose your port, and then you can hook in and use the data. And then we would have elaborate backup scripts to make sure that the data is not just on that single box. Yeah. But we were actually a big fan of using third parties to do the Mongo hosting. So part is still using third party Mongo hosting to make sure that we don't have to scale this thing ourselves. All right, so things that we could improve. I already touched upon it a little bit. We did the deployment with Fusion Passenger to the dislike of our main ops guy, who was really into Dockerizing everything. And I have to give him a fair right that would also be a better thing to do. So that's a part where we were focusing on in the next project to make sure that every instance of the application could be run as a container instead of having to manually install Nginx, manually having to install Fusion Passenger. You could of course use these scripts like mub and mubx. I don't know if anyone of you ever used these before, but it's just not the same as saying this is the application with all of the dependencies in it, with all the phantom.js and all the crazy dependencies that you would have, or the image creation software, or all these packages that you need, having them inside a container and being sure that if I run this container, it will actually always work, no matter where it is, or what dependency is installed, or what service is not running. So this was an improvement point there. Right, then we go to a next project that we're currently working on pretty hard as well, and we'll call it codename School. It's a higher school in Holland, and we're going to replace all of their Excel-based planning of exams. Going to create a nice repository of their curriculum and the subjects that are being given in each curriculum, which is like the how do you say this? The opmars, the first part of being able to create a fully digital experience for the students that are enrolling there, and the lecturers giving results and assigning study ASTS points, this kind of thing. And this was our like the next generation of our stack. We kept Meteor, so we kept the build tool and the hot reload and all this nice stuff from Meteor. We switched to GraphQL and Apollo, which was for us one of the biggest parts that was really different. We didn't use the DDP WebSockets anymore. We were now using request response again with the GraphQL part, because this application does not initially lean so much on notifications and on chats and on having all this data real time. So this was the perfect opportunity for us to switch from DDP to a GraphQL like environment. And this came with a whole bunch of other advantages that we were really not very likely to step back from GraphQL anymore, just because it's such a nice ecosystem and can solve things a lot more elegantly. Now maybe a question for everyone: how many of you have been to the previous MeteorNL Meetup? All right, so that was a lot about GraphQL and Apollo and getting started with it. So in this edition, we want to build up a little bit more upon that. So we'll not go into too much in depth into what GraphQL actually is. But if you're interested, you should probably talk to Martijn Walraaf, and he can explain you everything about it. So where was I? Oh yes, so we have the school. So in first sight would not lean as much as on the real-time data. So we're using GraphQL as the transport protocol. Sorry, as the schema and the API on the back end, and still using React, of course. I don't think we'll drop React soon as a front-end framework. Sorry? In favor of? In favor of Angular. So previously we used a lot of Angular, yeah, and still do for some projects that we're still maintaining. All right, so the school was basically API design on steroids.
You said, won't drop, right?
Sorry?
You said you won't drop React.
We won't drop React,
yeah.
And he was asked if we won't drop it in favor of. Yeah, it was.
I was thinking you all were going to drop it, but you are not going.
Oh no! We're staying with React. Yeah. The whole development team is already like standing up and leaving. No. All right, so the school we called it API design on steroids, and I'll elaborate on that in a second. It's just a very nice way of defining your API and getting the API more known to the front end team as well. All right, so what was great is the switch from to GraphQL Apollo and the request efficiency. So when we look back at bundling, the first project that we did a lot of REST calls to the backend, and sometimes we had to perform multiple REST calls to actually retrieve all of the data. So this would mean you would retrieve a bundle, and then separately you might retrieve comments that were listed on the bundle, or a separate request to request the amount of notifications that you had when you press the notification bar. Just one of the general things we found when we were switching to GraphQL was that we could really make most use of every request that was going out from the client to the server, because you could have multiple queries for different kinds of data. So you could at the same moment query the list of users and the specific bundle and maybe your latest notifications, and it would just go in one request to the server, resolve all the stuff, get back, and then get all the data to the right components, and we just have one request instead of doing this round trip a couple of times. So this was a really big plus here, and would also help us a lot when scaling these things out. One of the things maybe underestimated a little bit, I think sometimes, is how important it is that when you create your API in GraphQL, you will actually automatically document your whole API. So for a small project where you would be the front-end developer and the back-end developer in one as a full stack, you would think, oh, it's just a nice feature, but I already know my whole API. But just having the fact that someone can fire up your graphical debug interface and just pressing Control Space to see what stuff is available, it's just so valuable. And when we compare it to earlier projects that we did, you always had to create like a separate Swagger documentation or what was it, these other documentation tools to actually completely list, these are the REST calls you can do, and these are the parameters, and this is the description. And now you're not able to add stuff to the API that's not documented. Everything that you add to your GraphQL schema, you will see what the parameters are and what you need to pass to actually retrieve this data. And this was very important for us when we would transfer projects or have people drawn into the project, and just being able to open GraphQL and just see the options that are available very closely to how you would actually use it inside React. So this was a really big thing. Yes?
Can you generate tests from that?
So the question is, can we generate tests from the documentation? Yes, we'll actually touch upon testing GraphQL. So it's not actually generating the tests, but there are a couple of nice shortcuts that you can make to test out your GraphQL schema and the mutations that you do. But actually, generating tests should probably be possible. At least some simple tests to see if stuff is working. It's not something we've done yet. All right. So API definition by the front-end team is a nice anecdote where one of the front-end developers in the team was working on a new component where the back-end part was not developed yet, and we were actually able to have the front-end developer look at the previous API designs and create their own stubs on the GraphQL server, and basically define their own type, and have the query and the mutation that would actually change the data. And this actually did a lot of the setup work for actually implementing the backend part. But just having this easy access to extending the API without having to completely dive into this whole REST backend, which is separate and with complicated routings. We actually had a good success in having a lot of the design work done in tandem with front-end team, which was a great plus, and was also for me a big surprise that it would close this gap between front-end and back-end even further. Then we had the data loader for caching. So last time there was a lot of talk on how GraphQL worked, and basically you would have a layer in front of your application. The GraphQL request comes in, and then GraphQL takes care of retrieving the data from some place. So this place could be MongoDB, it could be Postgres, but it could also be a REST API or some other place on the web where you would fetch the content. But you can imagine that if you would do a request for say users within a certain area, or you would do 2 queries for users in a certain area, when this request comes in, you would actually retrieve the same users multiple times, because the query might result in multiple users being at the same place. And the data loader helped us to make sure that we would not repeat calls to the same REST backend or MongoDB backend that were already available or requested before, and this drove down our request, which was already very short, like 60 ms to what was it, 20? I think we divided the time in 3, because it just didn't have to request all these things from the database over and over again. So it was a very nice touch. So of course there's always something to improve, and this is actually one of the first telltale signs that we're moving away a little bit from the full Meteor stack. Is that we have quite heavy Meteor builds, and probably this has to do something with something we have done wrong in the process somewhere. But basically for us it means that we need a 2 GB box in the cloud somewhere to create the build without it running out of memory, while the application could easily run on a box with just 512 megabytes of RAM, and this is just a sort of a waste. It would make a lot of sense to build this image on your CI server and just run it on some box of 512 megabytes. But the Meteor build is doing all this kind of stuff that we don't have control over. So that's where we're experimenting with finding alternatives for this part. And of course, one of the main downsides is that there's no built-in real-time data. So we have to think of another way of doing this, but I'm already pretty confident that we can solve this using the GraphQL subscriptions that are coming up. All right, thanks. That's a good one. So before we go into the break, our latest and greatest codename course planning for a customer that does a lot of planning of language courses. So a lot of people want to do a language course, and they make sure they link it to certain teachers that can give language courses. Just a lot of calling and a lot of Excel sheets and a lot of hassle making sure that everyone gets to this lecture. And here we're for the first time switching away from the Meteor build layer, still using GraphQL and also using Apollo on the client, and using React on the front end. So we had a pretty big discussion about what part does Meteor still provide for us on top of having this great data layer with Apollo. And we found out like a list of stuff that was now being handled by Meteor, and we're just thinking about would it make sense to completely stay with this Meteor build tool, or could we do these things ourselves and stay closer to the GraphQL implementation, the Node.js how do you say this, life cycle. So we decided to give this a try. So we're still using the Apollo in the client, but on the back end we're basically going full circle to bare bones Node.js, and that's why we nicknamed the project Roll Your Own 2.0. So this we've learned a lot in the team. And we got more of a grasp on these opinions that Meteor made for us, and we're now able to make some of these decisions ourselves as well. All right, so good things in this new environment is that we have more control over the build. So the Meteor build is doing a lot of stuff. Compiling assets for the client and making sure that all the files are available, and for the backend it also does some processing that we're not completely sure what it is actually doing, which is one of the reasons we wanted to try it in a project for ourselves. So we have more control over the build and the compile time. So we've reduced the build of the process to just be an npm install or yarn install, and compiling the assets using gulp, and then just wrapping this in a Docker environment, and that's basically it. Still using the Apollo client because it was, we wanted to make this transition as little as possible, so we tried to keep as much from the old stack that we could. We still had the ES6, we still had the nice imports. We still had the nice React components that were completely separated. So actually, this step, and this is like a great thumbs up for the Meteor platform as it was now. The step of actually using our own build tool was actually quite minimal, and we were actually able to port a lot of the stuff that we used before to this our own. This is a build street. So that was actually quite surprising that it was so easy, and that we already structured the code in such a way that it was very modular. This also means that we're closest as we can get to the Node.js development cycle. Probably as you all have experienced, Node.js is cranking out versions. Node.js is then no, but something that takes a little amount of time. And yes, this means that we don't have to wait for Meteor team or package developers to switch to this new version, and we can stay up to date as quick as possible. Yeah, it's just maybe something a bit of a control freak thing from our side of things, but it draws us closer to the rest of the Node.js ecosystem as well, which I think is a good thing if we want to contribute with everyone to this Node thing that everyone is actually using at the moment. Yeah, we still do the data loader caching. Things that, of course, there's not a lot to improve, but because we invented this tech like a couple of months ago, so this is still the latest and shiniest one. But it does mean that we have to do some things ourselves, which might not be as much fun, and was one of my pro points for Meteor. Because we have to do the accounts part ourselves and everything, sending the emails and making sure that this part is the authentication and making sure that you can log in and you can register and all the stuff that the accounts package used to do for us. Hot reload, so making sure that when you just do a CSS change, you will actually immediately get the CSS loaded in your page and have clients instantly get the new version when you make a new deployment. And maybe most important of all, the development environment, because it's not as easy as just running Meteor and then you have your Node.js, your Mongo, and your migrations and all this stuff happening almost automatically. So that's something that we have to create ourselves right now, which takes some time but also gives you a lot of fine-grained control. Yeah, and this is like a previous project, also using the Docker images for Node and Mongo, and this is still a part that we're working on right now to make sure that during local development, you have a very quick development cycle of restarting an application.
How do you manage the hot reload?
Sorry?
How do you manage the hot reload?
To hot reload.
Yeah.
When you have a Meteor application, it will keep a WebSocket connection to the server, and you will subscribe to the current version of your Meteor application. And once you do a deployment on the server, and the client just stays active, the Meteor application is replaced, and it updates the version of Meteor, and then it will send through the WebSocket. It will send the client, hey, there's a new version, refetch the data, and it will actually fetch the new CSS and the new JavaScript and refresh itself.
And how do you do it?
And we currently don't do it. We just ask everyone to press Command R to refresh. But that's something that we have to work on. Yeah, right. Definitely.
So is the main reason to stop using Meteor the first bullet points? Yeah.
I think so. Now, actually, maybe I'll get to this in a second, okay? Before I give too much away, because I was getting there with the next slide. So it's basically the considerations of going vanilla Node. So a big part that it had to do in our team was also team maturity and the ability of our team to do all this selection of packages and making sure that all these site conditions are met. I can really imagine that maybe still for some projects we would start a Meteor deploy because it's just so easy to get started. But once you reach a certain level, you are also able to do these setups things yourself. So that's one part to take into consideration. Also, the necessity for opinionlessness, or your ability to choose everything yourself, to choose how you would want to log in, or how you want to register, or how you would want to do your forgot email part, or I'm just listing things from the accounts package now, but like making choices on which Node modules you want to use under the hood. For some teams it could make total sense, and for some it would not make any sense at all. So that's something that was important for us to decide. Of course, we have this third point, which is still an exciting one. Insert to be discovered missings here. So there's a lot of code written in Meteor. There's a lot of stuff done in there to make sure that you don't have to do it yourself. So we'll probably run into a couple of those while doing this project. So maybe at the next Meteor Meetup we'll tell everyone that the shiny new stack was with Meteor again, but we'll see. And basically, this last point I wanted to make that also maybe answers your question a little bit. Maybe it's just my experience, so this is not me talking from Meteor in some way, but I see Apollo as the current thing that Meteor is working on right now, really as a way for Meteor and the Node.js community to get closer together, because you're able to use Apollo as a drop-in in your Node, your barebone Node application, and it allows you to get a little bit closer to this new Node ecosystem that I was talking about. And I think this is a very good sign. And I think this will include both communities into one, and make sure that we can use the best of both worlds. So I could also imagine that maybe Meteor will, like the data part of being Apollo, will also separate other parts that are now in Meteor as drop-in replacements that you can actually mix and match your own framework using big parts of Meteor. So I would really be interested to hear this opinion of Meteor, how they're thinking about it. But that's just my humble opinion. So if there's anyone here or listening at home that would like to discuss this, please get in touch. All right, thank you for your attention.